exponential equations. Some of the properties, the biggest property with logs that we went over the past couple of days, or that you did in a day of expanding logs, was that if you have something like log base b of x to the n power, we can write that as n log base b of x. So we can bring that power down in front. It's what maybe people would think of as the power rule for logs. The other thing I want you to make sure is if we write log x, that's the same thing as writing log base 10 of x. And if we write log base e of x, that's the same thing as writing the natural log of x. Both of these is how a calculator works. Okay, so if you look at this Desmos calculator that I have over here, and it's that desmos.com/scientific, so you're going to need to know that. Desmos.com/scientific. That's how you get a really good calculator that you're going to need for this problem set. So if you go to functions, if you see it here, if you go to functions, what you'll see is you'll see natural log right there and log, and it doesn't have a base, so that's base 10. So those are the two things you can use for a calculator. And I'll show you how both of them work. We can do both of them. So let's take this problem right here. Solving this problem to the nearest hundredth. Okay, in algebra, if I wanted to solve this problem, what I could do is I could write, so if I have 8 times 2 to the x is equal to 1. If I want to solve this for x, I could divide by 8 and have that. Now, just like in algebra, whatever you do to one side, you got to do to the other side. So if I take the log of the left side, I would need to take the log of the right side. Notice that I have that exponent that is the power. Well, because of log properties, I can bring that power down. And I'm going to surround that with parentheses because I'm going to end up using that in a minute. Now, if I have it this is x times log 2. So x can equal log 1/8 divided by log 2. And I can do that on this calculator over here. I can type in log and go back to the main thing and do 1 divided by 8. Close the parenthesis. Oops, I don't want to close that one. Let me go back on this. Actually, let me get to here and let me here and delete that. Get out here and close that parenthesis and do divided by. Go to the function, hit log, go back to the main, hit 2. And what I'll get is -3. Now, I could do that same process with the natural log. So let me just show you how that would work. I could take 8 times 2 to the x is equal to 1. I could divide by 8 just like I did before, and then take the natural log of both sides. So that's log base e. Bring that x down. Divide by the natural log of 2 just like I did with the first one. And if I did that over here on my calculator, let me just hit enter, get a new line, and I go to function, natural log, go back to the main. If I do 1 divided by 8, and then I get over here, I close that parenthesis, divided by function natural log 2. Notice I got the same value. Well, that's good because that's what I wanted to get. I wanted to get the same value. I wanted to get this value of -3. So that's how you could solve that problem. We're going to do that same kind of thing with the next couple problems. So let's look at this next one. Solve this one to the nearest hundredth. So I don't care whether you use log or natural log. My bias is to use the natural log because it shows up in so many science classes. So that's what my bias is going to be. I don't know that you need to you could do it using just log if you wanted to. I'll show you that. Notice in my solution here and my solution here, the only thing that changed was whether I did the log or the natural log. And so I'm going to write the natural log, but then I'll show you how the calculations are the same. So if I'm doing this problem, first thing I'm going to do is divide by 66. So I have 10, 4x equals 81 divided by 66. If I take the natural log of both sides, the natural log of 10 to the 4x is equal to the natural log of 81 divided by 66. Now, because I have that power and I have that natural log, I can bring that power down in front. So 4x natural log 10 is equal to natural log 81 divided by 66. One of the things with multiplication, and we just have multiplication here, is we can rearrange it. So I can rearrange it to look like this. And as long as it's multiplication, we can rearrange it. 3 times 4 is the same thing as 4 times 3. So then if I do that, then to solve this, I'm just going to divide. And I'm going to make sure that I can use a calculator, which I can on this one. And I'm just going to divide by 4 times the natural log of 10. If I go over to my calculator, and I go over here and I go to function, and I do natural log, go back to the main, I do 81 divided by 66, and I close that parenthesis. Now I'm going to divide by, and I'm going to divide by all the stuff in this denominator. So 4 times the natural log of 10, and close the parenthesis. There's my answer. X is equal to 0.022, or as far as delta math is concerned, 0.02. Now I just want to show you that if I change this thing to log, so if I go over here and I do, let me do enter here. If I do log 81 divided by 66, and close the parenthesis, divided by 4 times log 10, I get the same value. Notice that those are the same values. So it didn't matter whether I use log or natural log. I get the same value. And it's just algebra. Whatever I've done to one side, I do to the other. If I go through those steps, this first step, I divided by 66 to get rid of the 66. Then I took the natural log of both sides. Then I did the power rule. I did rearrange it, and then I divided by everything without x. So go back and review that. Now, let's say I have this problem. An element decays radioactively. The half-life is 5 minutes. There are 520 grams of element X. How long to the nearest tenth of a minute would it take the element to decay to 92 grams? So, in this problem, some of the pieces of information, half-life is 5 minutes. That means in this problem, H is equal to 5. We're also given that there are 520 grams, which means A is equal to 520. The question is asking, how long would it take to get down to 92 grams? That means Y is equal to 92, and the question is find T. So let's write what I got out here. In this problem, I have 92 is equal to 520 times 0.5 to the T divided by 5, because that's the half-life. Okay, so in here, if I go through and I do all the steps of algebra on this, the first step of algebra I'm going to do is I'm going to take 92 and I'm going to divide by 520. And I still have this left over, only I got this exponent. So how do I get rid of that exponent? I take the natural log of both sides. So if I do that, natural log of 92 divided by 520. Sorry, my writing wasn't great there, but that's 520. It's equal to the natural log of 0.5 to the T over 5. Now, because of that power, I get to pull that power out in front. So if I pull that power out in front, go over here and continue solving this, and I write the natural log of 92 divided by 520 would equal T divided by 5 times the natural log of 0.5. Now, in here, if I go through and I divide by the natural log of 0.5, the natural log of 92 over 520 divided by the natural log of 0.5. Still have T divided by 5 here. So how do I get T by itself? Multiply both sides by 5. And if I did that, I'd have 5 times the natural log of 92 over 520 divided by the natural log 0.5 is equal to T. So that's what I'm going to do over here. I'm going to do 5 times. Now I'm going to go to my function, type in natural log. I'm going to do 92 divided by 520. I'm going to close that parenthesis. Then I'm going to divide it by. And I'm going to do natural log 0.5. Close that parenthesis. There's my value. Based on my calculator, my value. And it wants me to do it to the nearest tenth of a minute. So at 12.49, the nearest tenth of a minute is 12.5. That's the value that I'd put in. Go back and review that one before you do the problems if you need to. So let's look at this last problem here. Person invests $3,000 in a bank. Well, that $3,000 is going to go in for P. The bank pays 4.25% interest rate. That's going to be our R. Compounded semi-annually. Semi-annually is going to be N, where N is going to equal 2, because semi-annually means twice annually. Annually would mean per year. So semi-annually would be twice a year. So now, how long must a person put money in the bank until it reaches $5,600? So that one, 5,600, oh, let me use a different color. 5,600, let's see, I'll use this blue. 5,600 is going to be A, and then we'd be solving for T. So let's write all the things that we have in here. Okay, write it all down here. 5,600 is equal to 3,000 times 1 plus R, which is 0.02425, because that's the rate as a decimal, divided by 2 to the 2 times T. Now I'm going to go through and solve this. And I know the numbers are not going to look right, and I'm not going to do a lot of simplifying because I'm just going to use the calculator to calculate it. So just bear with me as I do this. First thing I'm going to do is divide by 3,000. So I'm going to have 5,600 divided by 3,000. Still have 1 plus 0.0425 divided by 2 raised to the 2 times T. Next thing I'm going to do is I'm going to take the natural log of both sides. So I'm going to natural log 5,600 divided by 3,000 equals the natural log of 1 plus 0.0425 divided by 2 to the 2t. That power allows me to pull that 2t out in front. So natural log 5,600 divided by 3,000 times, or equals 2t. And then I have, get my eraser here, natural log 1 plus 0.0425 divided by 2. Now to get t all alone, I divide by those pieces that don't involve t, because that's just multiplication right there. So natural log 5,600 divided by 3,000 divided by 2 times natural log 1 plus 0.0425 divided by 2. So all I did was I just did a bunch of algebra. If you think about that process that I just did, I inserted those values, stepping through the first step, divided by 3,000. The next step, took the natural log of both sides. The next step, used the power rule to bring the 2t down. The next step is divide by both 2 and that other natural log stuff. Now I'm going to use the calculator over here. So I'm going to do the natural log. Now I'm going to do 5,600 divided by 3,000, close the parenthesis, divided by, I want to divide by all this stuff, 2 times the natural log of 1 plus 0.0425 divided by 2. And now I just got to close all my parentheses in here. Delta math, or Desmos shows me when I get there. What I end up with is t is equal to 14.841. Now let me look at what Delta Math wanted me to list it as. Delta Math told me to the nearest tenth of a year. So that's 1 decimal place. So my answer for Delta Math would be 14.8. Hopefully that makes sense to you. Ask me questions if you need help.